To grab a snack from a machine is to interact with a surprisingly complex frontier of modern engineering. For decades, breakrooms and cafeterias housed thousands of these isolated metal boxes, scattered across the country with zero connection to a central network. Managing them required manual labor. A route driver would show up with a clipboard, manually count the remaining bags of chips, and guess what items to restock. This created massive financial friction. Drivers arrived at machines completely blind to what was inside. They carried the wrong items, wasted time on their routes, and lost out on potential sales. Turning these disconnected offline boxes into a highly profitable synchronized digital fleet requires building a bespoke Internet of Things ecosystem from the ground up. In network engineering, the edge is the physical point where digital systems meet the real world. For unattended retail, agile startups took the first swing at bridging this gap. They started by physically hacking legacy motherboards. A company called Gimme built the Gimme Key, a small Bluetooth dongle designed to plug directly into old hardware and pull exact inventory numbers. Today, enterprise manufacturers take this physical footprint much further. Companies like Seco replace the entire interface using their modular vision system, swapping out plastic buttons for 15.6-inch interactive touchscreens. Whether deploying a small dongle or a massive display, planting a piece of connected hardware inside the machine is the required first step to extracting usable data. But extracting edge data is useless if it sits isolated on a motherboard. It has to travel from the machine to the human operator servicing it, a step known as the transport layer. Digital interfaces quickly replace the clipboards. Drivers could open a mobile app and instantly compare a machine's actual scanned inventory against the precise numbers the system suggested they load. Faster, more urgent tone. Moving that data is difficult in the physical world. During Guinea's initial 42 machine rollout, their tablets relied entirely on active cellular connections. When drivers entered dead zones, like basements or deep inside warehouses, the synchronization crashed and the application froze. The engineering resolution required building a resilient offline mode. The application had to store data locally and function normally, waiting to sync the fleet's data to the network only when a cellular signal returned. A successful data pipeline has to survive the disconnected, messy physical environments where these machines actually live. When you zoom out from a single delivery route to tens of thousands of machines, the volume of data multiplies rapidly. You need an enterprise-grade cloud architecture to organize it all simultaneously. This diagram shows Seco's Clea platform architecture. As data moves upward from the physical machine, it splits. One stream feeds into a module called a startee, which orchestrates incoming telemetry, like drink counts and temperatures. The other stream connects to Edgehog, which manages the physical controls and software updates. Because this open-source architecture is flexible, operators can plug older, third-party machines into the exact same network, avoiding ripping out expensive legacy hardware. True enterprise scale happens when software is flexible enough to adapt to mixed fleets of real-world equipment, rather than forcing operators into a single proprietary ecosystem. With the hardware installed and the cloud connected, the vending machine drops its status as a blind metal box. It operates as an active, secured node in a living network. Operators can now monitor live telemetry, execute real-time cybersecurity anomaly detection to block digital threats, and push new software or advertising files to the touchscreens remotely. By aggregating millions of data points across the fleet, operators can train predictive artificial intelligence models to recognize slight changes in voltage or temperature. They identify a failing compressor days before the drinks ever get warm. This connectivity creates a new economic model for the industry. Instead of relying on one-time hardware sales, companies generate recurring revenue through a software-as-a-service model, charging operators a monthly subscription fee for every connected machine. The most sophisticated leaps in data engineering don't exist exclusively in pristine server farms. Sometimes they are executing thousands of queries a second, sitting quietly in the break room right behind the glass.